Hi, it's Mrs. Pope, and today we're going to talk about radical expressions. This is part 2. Our goal is to multiply and divide radical expressions, and we're going to start out with multiplying, and then, of course, we're going to move on to dividing. So here we have 5 times the cube root, negative 12ab to the 4th, times 3 times the cube root of 18a squared b squared. Notice these are both cube roots, so we can multiply them together and basically put them under one big house. What I mean by that is, we'll take the 5 and the 3, of course, the coefficients, we'll multiply those, but then we can turn this into the cube root of all of these together. So negative 12 times 18 times, I'll need a bigger house, a times a squared, and then b to the 4th times b squared. So we've multiplied everything underneath. Now let's just go ahead and simplify it. So we have 15, of course, that's not going to change. Cube root of negative 12 times 18 is negative 216. A, remember that's like a to the 1st, so a times a squared, a cubed, b 4th times b squared, b to the 6th. And I'm happy with this being a cube because I want to divide it by that 3, and it's perfectly divisible. The 6 is perfectly divisible by that as well. So what we have here is 15 times the cube root of negative 216 would be negative 6. And then this, of course, is going to be a cubed divided by the 3 from here. And we have b to the 6 divided by the 3 from here. So our final answer would be negative 90, a, because that's just 1, b squared. All right, let's look at another example. Okay, example 2, same idea. Let's go ahead and multiply. So of course we want to first take the 6 and the 4. We'll get 24 times the square root of 8 times 2 times c cubed times c times d to the 5th times d cubed. Simplify it all. 24 times square root of 16 c to the 4th d to the 8th. Remember, this is an imaginary 2 out here when we have a square root. We just don't write it. So I'm going to have 24 square root of 16 is 4. And we also have c to the 4 over 2, d to the 8 over 2. So if we simplify here, we have 4 over 2 are just squared, 8 over 2 are to the 4th. So our final answer, 96 c squared d to the 4th. All right, moving on. Here's a key concept before we move to our next example, and it's the quotient property of radicals. So if we have the nth root, whatever the degree, or whatever the n is, of a over b, we can break that down into the nth root of a divided by the nth root of b, if all roots are defined. Let's see what that means. It can go either way. If you have the square root of 27 over the square root of 3, that also is the same as the square root of 27 over 3. Now you may say, why would we do that? Well, I can't take a perfect square of 27, can't do it with 3. But if I divide here, I'm now left with the square root of 9. And I can, in fact, take the square root of 9 because it's a perfect square. So my final answer would just be 3. So a little bit of vocab. Before we move on, rationalizing the denominator. We're going to do this in a little bit. When you hear me say rationalize the denominator, this is a method that's used to eliminate radicals from the denominator. And if you remember, expressions aren't in simplest form if there's a radical in the denominator. So we're going to do something called rationalize. We've already done this a little bit earlier, but it's coming back in a different form. So example 3 says simplify. X to the 6 over y to the 7th. Well, let's start with what we know. We can use the quotient property. So then this will turn into square root of x to the 6th over square root of y to the 7th. But has that helped us any? Remember, we can't have radicals in the denominator, so we use the quotient property to get here, but we need to fix this. We need to fix that because we have a radical in the denominator and it's a square root. And I can't take the 7 divided by the 2 because that won't help me. Well, let's make this divisible by 2. Let's just add one more of these. So we're going to multiply both the top and the bottom by radical 7. And let's see radical y, and let's see why. So radical x over 6 times radical y to the 7th. What we're going to do is multiply by radical y over radical y. And let's see why that works. The top hasn't really changed much. We have, let's see, oh, we can simplify this because that's a square root. So the top really is x to the 6 over 2, right, because of the square root, radical y. And the bottom now is radical y to the 8th because I can multiply those two together. So if I have y to the 8th, that's better because it's divisible by 2. So simplifying this, we're going to have x cubed radical y over y to the 8 over 2, which is of course just going to be y to the 4th. Now we've rationalized the denominator. And what we did here was we multiplied the numerator and the denominator by a quantity so that the radicand has an exact root. So the y to the 7th was a problem, but if I multiply and give it another y, I have y to the 8th, and I can divide it evenly by the 2. So we rationalized the denominator by getting rid of that radical in the denominator. All right, let's try it again. Simplify a to the 9th over b to the 5th. Notice the 5th is the problem because we need to get rid of that radical sign. Well, I can't divide 5 by 2, but let's add another one. Let's make it 6. So we're going to multiply this by radical b over radical b. That's going to leave us then a to the 9th, or radical a to the 9th times radical b over radical b to the 6th. Okay, so the bottom we can take care of. The top, this 9, there's a problem there because it does have a perfect square in there. We can factor one of them out, but it's just written where that we can't see it. So we're going to rewrite this 9 as an 8 and a 1. You just have to play with it. So we're going to rewrite this as radical a to the 8th a radical b. And remember, this is now b to the 6th over 2, which is just going to be b cubed. And the reason we did this, because now I can factor out, or I can take the square root of that and get rid of it. So here we'll have a to the 8 over 2, and we still have radical a, and we still have radical b. And down here we have b cubed. So last step to simplify, the 8 over 2, of course, is going to be a to the 4th. These are both under the same radical, it's a square root. And that will be our simplest term. A to the 4th, radical AB over B cubed. All right, let's look here at example 5. Here we have the 5th root of 4y, or 3 divided by 4y, and 4y needs to be a perfect 5th root. So we need to make this something that I can take the 5th root of, and it'll be perfectly even. Well, first thing we're going to do is figure out what I can multiply 4 by to be a perfect 5th root. Well, 32 happens to be a perfect 4th root, or 5th root, and I can multiply this by 8 to make that happen. So I can multiply by 8, and the y, if I just make it y to the 5th, by adding 4 more y's, it'll be a perfect 5th root. So what we're going to multiply by on this one is, what did I say? I forgot already. 8y, 5th root of 8y to the 4th. And then when we do the top, 5th root of 8y to the 4th. So let's see why that works. Here now I have, and that one, then you can divide that up. So here I should have the 5th root of 24, because the 3 times 8, y to the 4th. And on the bottom, I should have the 5th root of 32y to the 5th. So the top, I can leave it how it is. 5th root, 24y to the 4th. There's nothing I can do to simplify that. And on the bottom, these are perfect fifth roots. The fifth root of 32 is 2. The fifth root of y to the fifth is just y. So this will be our final simplified answer. I think we have one more example. Yep, last example. Using a conjugate to rationalize a denominator. One more way, we did this with imaginary numbers, so this is not new, but it's just the same idea. The conjugate, if we have to simplify 2 over radical 5 minus 1, the conjugate is radical 5 plus 1. So we'd multiply both sides by radical 5 plus 1. And you'll see how it'll magically make the radical get out of the denominator. So the numerator, we have 2 times radical 5 plus 1. If we simplify that, 2 radical 5 plus 2. Now the denominator, we have radical 5 minus 1 times radical 5 plus 1. 2 binomials, we're going to FOIL them. First, outside, inside, last. So here we have radical 25 plus radical 5 minus radical 5 minus 1. Of course, this is just 5. These cancel out. Minus 1. Final answer is 4. So our numerator is 2 radical 5 plus 2. And they're all over 4. And I would simplify this, 2 radical 5 over 4 plus 2 over 4. And of course we can reduce the fractions. That becomes a 1, that becomes a 2, a 1, a 2. So your final simplified answer, radical 5 over 2 plus 1/2. All right, thanks for watching, and remember you are responsible for your own learning.